Good day. For this video, we will talk about how to find the current truth and the voltage across each resistors. In our last video, we are discussing about solving the series and parallel circuit with techniques. If you haven't watched yet already, the link is on below description. Today, we discuss how to find the current and the voltage through each resistors. So let's start it by reviewing our topics about series and parallel circuit video. In series, the current flow through each of the component is the same, and the voltage across each circuit is the sum of individual voltage drop of each component. In parallel, the voltage across each component is the same. The total current is the sum of the current flowing to each component. So let us proceed to our question here. Find the current through the voltage across each resistors. So we are about to simplify first by calculating the equivalent resistance or RT of this circuit. So by applying our tricks and techniques that we discussed with our last video, we have to calculate first the R4 and R5 because the two is connected in series. So with the formula of series, RT is equal to R1 plus R2. Just simply substitute and add the two resistors which equivalent to 4 ohms. After this, we will redraw the circuit and simplify. So now we can see that R2 and R equivalent 1 is connected with parallel. By our tricks and techniques, when the two resistors are connected in parallel with the same value, the equivalent resistance is simply half of their value. So the answer is 2 ohms. After this, we will redraw again the circuit and simplify. We see that the circuit is on series, so by the formula of series, just simply add the 3 total resistors for equivalent to 6 ohms. After this, we will now calculate the total current with the formula coming from the Ohm's law triangle. So by the formula, I is equal to V over R. Just simply substitute the given voltage and resistance. I is equal to 12 divided by 6 ohms is equivalent to 2 amperes. We will back to our last circuit. So we all know that in series, the current flow through each of the components is the same. So we know that the current going through first resistors is also equal to 2 amps, as well as the second resistors and the third resistors also have 2 amperes. After this, we will now find the voltage across each resistors. So by the formula of voltage, V is equal to I times R. So we know that in series, the voltage across each circuit is sum of individual voltage drop of each component. So by simplifying the formula, V1 is equal to I1 times R1. By substituting the current and the resistance, 2 amperes times 2 ohms is equivalent to 4 volts. In V2, I2 times R2 is equivalent to 4 volts. In V3, I3 times R3 is equal to 4 volts. So when you add the 3 voltage drop, V1 plus V2 plus V3 is equivalent to 12 volts. So let's back to our previous diagram earlier. So we know already that the current through R1 is 2 amperes and the voltage across R1 is 4 volts. And we all know also that the voltage through R3 is 2 amperes and the voltage across R3 is 4 volts. So now, let's try to solve of these two resistors. So we all know that the voltage leaving to our battery is 12 volts. And we know once we go across R1 is 4 volts drop. So by subtracting 12 minus 4 volts is equal to 8 volts. So the voltage after across R1 is 8 volts, which means the voltage over here is also equal to 8 volts because we haven't crossed any resistors. Same as the end of the circuit. We know that the voltage at the end of the circuit is equal to 0 volts because the potential always goes to 0. We know that there is 4 volts drop across R3. So by adding 0 plus 4 is equal to 4 volts. Same as the voltage over here is also a 4 volts because we have not crossed any of resistor. We know that before we cross R4, we have a voltage of 8 volts. And once we cross that resistor, it goes from the 8 to 4 volts. So when we subtract 8 minus 4 is equivalent to 4 volts. So we know the voltage across R4 is 4 volts. And same thing that's gonna happen with this resistor. We know that in parallel, the voltage across each component is the same. So 8 volts minus 4 volts is equal to 4 volts. And now we will find the current going through of these resistors. In parallel, the total current is the sum of the current flowing of each component. By the formula of current, I is equal to V over R. R4 is equal to 4 volts over 4 ohms, is equivalent to 1 ampere. So therefore, the current going through R4 is 1 ampere. And the same thing with R5. I5 is equal to V5 over R5, equivalent to 1 ampere. So now, the only thing we left are these two resistors. So once we solve these two resistors, we have to completely solve our entire circuit. We know that in series, the current flow through each of the components is the same. We know that the current going through this resistor is 1 ampere, same as the second 1 ampere. The only thing we left to do is to calculate the voltage across each resistor. So with the formula of voltage, V over I times R. V6 is equal to I6 times R6 is equivalent to 2 volts. And the last one, V7 times I7 times R7 is also equivalent to 2 volts. And now it makes sense because 2 volts plus 2 volts is equivalent to 4 volts. Because the voltage across this resistor is exactly the same as the voltage across this resistor. And now we have officially found the current through and the voltage across each resistors in this circuit. So that's all for today. Thank you for watching, and don't forget to click subscribe to this channel, and don't forget to click the notification bell for you to be updated in my next video.